Module 3, Lesson 15, Locating Ordered Pairs on the Coordinate Plane. So here's our two big learning targets for this section of the module. We want to be able to solve real-world problems, real-world and mathematical problems using the coordinate plane. And we want to use coordinates and absolute value to find distance between points on the coordinate plane. That's our two big learning targets for this section. For this lesson, we want to be able to draw a coordinate plane and label the following: the x-axis, the y-axis, quadrants 1, 2, 3, and 4. We want to be able to identify the origin. We want to locate and draw points which lie on the axis. So they're not in a quadrant, they're actually on the axis. And we want to locate points on the coordinate plane in all four quadrants using ordered pairs of integers and other rational numbers. So not just whole numbers, as it were, but we've also got fractions and decimals. So pause for a moment and ask yourself, what do you know about each of the following terms? Maybe write yourself a little description, or maybe draw a picture and label these things. We will be talking about each of them as we go through the lesson. So describe the x-axis. What types of numbers should it include and why? If you were talking about the x-axis, what can we say about it? Well, hopefully we can say that the x-axis is a horizontal line, which means it's running left and right. Hopefully we can say that it's going to have positive numbers and that it's going to have negative numbers. And hopefully we can say that it will have integers and that it would also have rational numbers. We could put fractions and decimals on it. So the point below represents 0 on the number line. We're going to draw a number line to the right starting at 0 and then follow the directions as I give them to you. So we are going to draw a number line to the right starting at 0. So we're going to start right here. This is 0, and we're going to draw a line to the right. Then we are going to take and draw to the left. We are going to create our scale. And it's important that we understand, and if you remember back, I think we did an activity with, well, in class we do it with compasses or a ruler or something to make sure that we're spreading the numbers out equally. So I'm going to try a little more careful than I normally do to make sure that I'm getting them close to the same distance. 1, 2, 3, 4, 5, 6, and I didn't do great, but I tried. And I'm now going to do the same on the left, trying to keep the same scale. The scale is how far apart the numbers are and what we're counting by. And it's important we try reasonably to keep our scales the same. All right, so I have my x, which is my horizontal line, running left and right. I have counted by ones on each side. I've got my positive section, I've got my negative section. So the y-axis. What type of numbers should it include? And the answer is very similar to the one we gave for the x-axis. The y-axis is a vertical number line, and it will have positive and negative numbers. So we are going to get out our straight edge, and my straight edge isn't very straight because I don't have one on the smart panel that I'm using, and I am going to draw this vertical line, and it also needs to pass right through my dot there, and I am going to use the same scale, going to count by ones, trying to keep my lines the same distance apart. and I am going to label each of those. So as I said kind of at the conclusion of the last lesson, we create this grid using a horizontal number line and a vertical number line. The horizontal number line represents the x-axis, and the vertical number line is for the y-axis. All right, we've already done that. All right, so all points on the coordinate plane are described with reference or in comparison to or starting at the origin. So what is the origin and what are its coordinates? I didn't erase this off my board so that we could look at it and we could say, okay, what is the origin here? Well, the origin is where the x and y axes intersect, where they cross each other, which means that we are at 0 on the x-axis. We haven't gone any left, we haven't gone any right, and we are at 0 on the y-axis. We haven't gone any up and we haven't gone any down. So this is the origin right here, 0, 0. To describe locations of points in the coordinate plane we use, think about this, what would we put inside of this blank? Hopefully you're thinking of the last lesson where we talked about we use ordered pairs of numbers. Order is important, so that on the coordinate plane we use the form the x coordinate first and the y coordinate second. And please notice that we use these parentheses around them to indicate that these are ordered pairs. The first coordinate represents the point's location from 0 on the x-axis. So we have our x-axis that has a 0 on it, and we are being told how far we are from that point. The second coordinate represents the point's location from 0 on the y-axis. So I've got my vertical number line, this is 0 on the vertical number line, and we're saying how far are we from that 0. Exercise 1, graph at least 5 points on the x-axis and label their coordinates. So we want them to be right on the x-axis. So pause the video, find 5 points that you can put on your x-axis and then write down their coordinates. On the x-axis, so that means I need to be right on this line here. And I've got one at 0, well, not 0, let me try that again. So I went 2, and I didn't go up or down. 1, 2, 3, 4, 5, 6. I went 6, and I didn't go up or down. I went -3, and I didn't go up or down. And I went, let's see, -6, and I didn't go up or down. And I went -9, and I didn't go any up or down. So I've got 5 points that are right on the x-axis, and if I look at them and answer the question, what do they have in common? Well, they all have a 0 as their y-coordinate. Or second coordinate. So this part C here, what must be true about any point that lies on the x-axis? If a point is on the x-axis, then the second coordinate, the y-coordinate, is 0. And that's true about any time a number is on the x-axis. So if somebody gives me a coordinate and asks me, is that on the x-axis, I can look and say, yes it is, because the second coordinate is 0. If somebody gives me an ordered pair, and says, is that on the x-axis? I can look at it and say, no, that's not on the x-axis, because to be on the x-axis, it has to have a second coordinate that is 0. All right, so now we're going to put 5 points on the y-axis, and we're going to label their coordinates. So they've got to be right on the line here. And the y is the vertical line. All right, so I haven't gone any left or right, so I've got a 0, and I went up 1, 2, 3, 4, 5, 6, 7, and I didn't go left or right, so I've got a 0, and I went up 1, 2, 3, 4, and I went up 1. And I didn't go any left or right, but I went down 2, that's a negative 2, and I went 2 more, 2, 3, 4, no, I went 3 more, 5, 5, 6, 7, 8. So looking at my 5 points that are on the y-axis, what do all of them have in common? The first coordinate or x-coordinate is 0. And that is true of every single point or ordered pair that is on the y-axis. Any point that lies on the y-axis is going to have a first coordinate that is 0. So if somebody comes to me with an ordered pair and they say, is that on the y-coordinate? I can look at that, sorry, is that on the y-axis? I can look at that and say, yes it is. And they look at me and they're like, but you didn't even put it on the coordinate plane. How do you know? And I say, I know because the first coordinate is 0, which means I'm not moving left or right. The x value is 0, so I'm on the y-axis. The second one tells me how far up or down to move. Exercise 3. If the origin is the only point with 0 for both coordinates, what must be true about the origin? So the origin is here. It has 0 and 0 for its ordered pair. So what is true about the origin? Stop and think about that for a moment. What must be true about the origin? Well, if we know that a point that has 0 for the x-axis is on the y-axis, so 0 for the x-coordinate is on the y-axis, and if I know that a point that has a 0 for the y-coordinate is on the x-axis, I combine those two things and say the origin is on both axes. It's on the x-axis and on the y-axis. It's on both of them. Because remember, a number that has a 0 for the x-coordinate is on the x-axis, and a number that has a 0 for the y-coordinate is on the y-axis, which means the origin is on both of them, and it's the only point that is on both of them. The x and y axis divide the coordinate plane into regions called quadrants. Why do you think that these regions are called quadrants? So we have the x-axis, x-axis, and the y-axis. Why do you think that they call these sections here quadrants? And hopefully your brain is screaming at you because there are 4 of them and quad means 4. The regions are called quadrants because there are 4 regions and quad means 4. So which of the 4 regions have you worked the most with? So you've probably been doing stuff with coordinate plane for a long time. Which of these 4 have you probably worked the most with? And the answer is you've probably spent most of your time here. And the follow-up question to that is, why? Why have you spent most of your time there? And the answer to that question is because these are positive numbers. That section right there is positive y numbers and positive x numbers. You haven't, up to this point, done a whole lot with negative numbers. You've done some things, but you haven't done a lot. So you have spent time in this section because this is where positive x and positive y are. The four quadrants are numbered through 4 using Roman numerals. The upper right quadrant is quadrant 1. And then we go counterclockwise to quadrant 2, quadrant 3, and quadrant 4. So clear back in example 1, back when we started the lesson, we expanded an axis. We started with our point and we drew this line right here, and then we came back and we drew this line. And when we drew that line, what we found is that we all of a sudden had negative numbers. We had positive when we started, but then we had the negative numbers. When we dipped into those negative numbers, we all of a sudden revealed this new region of the coordinate plane. So this top left region is called quadrant 2, and I've labeled it quadrant 2. These two right here are only half the coordinate plane, which is pretty obvious if you look at what I have on the screen. The remaining half of the coordinate plane is of course down here, and that comes when we extend the y-axis down into the negatives. Let's see, we've already done that. Okay. Something I would quickly, oh no, we'll do this in just a second. Okay, so we're going to locate and label each point by the ordered pairs, and we're going to tell which quadrant they go in. So I need to find 7, 2. 1, 2, 3, 4, 5, 6, 7. 1, 2. And so there's point A. I'll put an A there. And that's in quadrant 1. I've got 3, negative 4. So 1, 2, 3. Negative 4. 1, 2, 3, 4. And that's going to be point B, and that's in quadrant 4. Remember, we go counterclockwise: quadrant 1, quadrant 2, quadrant 3, and quadrant 4. All right, I've got 1, negative 5, so I'll go over 1 and down to negative 5. 1, 2, 3, 4, 5, and that's point C, and that's in quadrant 4. I've got negative 3, 8, so 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, and that's going to be point D, and that's in quadrant 2. And I've got negative 2, negative 1, so 1, 2, and negative 1, and that's point E, and that's going to be in quadrant 3. So we're now going to write a set of coordinates that goes in each of the 4 quadrants. So if I wanted something to be in quadrant 1, what coordinates would put me in quadrant 1? Well, I'd go over 2 and up 5, and that'll put me in quadrant 1. For quadrant 2, I've got to go into the negatives for x, and then I've got to go into the positives for y. So negative 3 and 4. And if I'm doing quadrant 3, I need to go into the negative x's, and I need to go into the negative y's. So negative 8, negative 3. And then for quadrant 4, I've got positive x's and negative y's. So 5 and negative 2. So what we're looking at here is kind of a pattern, or a recognition of a pattern, that in quadrant 1 the coordinates are always positive, positive. The x-coordinate is positive and the y-coordinate is positive. For quadrant 2, the x-coordinate is negative and the y-coordinate is positive. So I go negative on the x and then I go into the positive section of the y. For quadrant 3, I'm doing the negative section of the x, and I'm also coming down into the negative section of the y. And for quadrant 4, I'm going into the positive section of the x, and then I'm going into the negative section of the y. So as I look at points in the coordinate plane, if I recognize and remember that pattern, I can tell something about coordinates just by looking at them. If I have 2 positive coordinates, that means I'm in quadrant 1. If I have 2 negative coordinates, that means I'm in quadrant 3. If only one of the coordinates is negative and one is positive, then I'm in quadrant 2 or 4, depending on which is positive and which is negative. Alright, so if a point lies on an axis, what must be true about its coordinates? So if it's on an axis, one of the coordinates has to be 0. Specifically, what is true for a point that's on the x-axis? If it's going to be on the x-axis, then the y has to be 0. The first number is going to move me left and right, but the second one is not going to do anything. It's going to stay as 0 because I'm not moving up or down. For the y-axis, I'm not moving left or right. All I'm doing is moving up or down. The y-coordinate is always 0 if a point is on the x-axis. That second coordinate is 0. The second coordinate is 0 if I'm on the x-axis. No up and down movement. The x-coordinate, the first coordinate, is 0 if I'm on the y-axis. I'm not moving left or right, I'm just moving up or down. What do you know about the location of a point on the coordinate plane if both coordinates are positive? And I just pointed this out. If I've got x and y, they're both positive. That means I'm moving this way and moving this way. That means that I am in quadrant 1. If both coordinates are positive, the point must be located in quadrant 1. What if only one of the coordinates is positive? Well, I could be in quadrant 1, or I could be in quadrant 2, or I could be in quadrant 4. If only one coordinate is positive, the point is either in quadrant 2 or quadrant 4. Now I included quadrant 1 because it's both positive there, but if it's only one, if you've got one positive and one negative, then quadrant 1 doesn't fit. If only one of them, if exactly one is positive, then it's quadrants 2 and 4. If the first coordinate is positive, it's quadrant 4. If the second coordinate is positive, then it's in quadrant 2. And if both coordinates are negative, we're in quadrant 3. And if one coordinate is 0, we're on the axis, x or y. Both coordinates are 0, we're at the origin. So the x-axis and y-axis of the coordinate plane are number lines that intersect at 0 on each number line. The axes partition the coordinate plane into 4 quadrants. So here's x, here's y, 4 quadrants, 1, 2, 3, and 4. Points in the coordinate plane lie either on an axis or in the quadrant. So a point that is on the axis isn't in a quadrant, it's on the axis. So points can either be on the axis or they're in a quadrant. All right, quick review of the I can statements. Hopefully you're feeling pretty good about these. Drawing an x-axis, drawing a y-axis, labeling quadrants 1, 2, 3, and 4, identifying the origin, locating and drawing points that are on the axis, and locating points on the coordinate plane in all four quadrants using ordered pairs of integers and other rational numbers. And all of these are steps towards our learning target of being able to solve real-world and mathematical problems using the coordinate plane and using coordinates and absolute value to find the distance between points on the coordinate plane. That concludes Module 3, Lesson 15. Make sure you complete your problem set and your exit ticket. If you need help, make sure you reach out to your teacher.